Complex numbers. Part 5.
Hi, hello everyone. For this session, we will discuss few problems. So, see the first one. Find the polar form of the complex number. So, see here. Given complex number, that is z is equals to -1 minus root 3a. So, you know that z is equals to what? R times of cos theta plus I sin theta is equals to -1 minus root 3a. So here what is R value? R is equal to square root of x square plus y square. So here x is equals to -1, y is equals to -3. That is 1 plus 3 will get 2. So this is equation 1. So now equation 1 implies 2 into cos theta plus I sin theta is equals to -1 minus root 3a. So now we are comparing the both real and imaginary parts. So what you get? 2 cos theta is equals to -1 and 2 sin theta is equals to minus root 3. So therefore cos theta value is -1 by 2. Sin theta value is minus root 3 by 2. So see here, x is negative, y is negative. So x is less than 0, y is less than 0. So then theta lies in third quadrant. So therefore argument of z is what? Minus pi plus theta. So but what is theta value? Theta value is 60 degrees. Cos 61 by 2 sin 60 root 3 by 2. So therefore argument of z is equals to minus pi plus 60. So this is minus 120. It is minus 2 pi by 3. So therefore the polar form is here -1 minus root 3i is equals to 2 times of cos theta. So that is cos of minus 2 pi by 3 plus I sin of minus 2 pi by 3. So this is the polar form of a given complex number. So see the next one. -1 minus I. So let z is equals to -1 minus I. So x is equals to -1, y is equals to -1. So therefore r is equals to what? Square root of x square plus y square. That is 1 plus 1, you will get root 2. So you know that z is equals to what? R times of cos theta plus I sin theta. So what is z value? That is -1 minus I is equals to R times of cos theta plus I sin theta. So this is equation 1. So now see here, this is -1 minus I is equals to what is R value? Root 2. So root 2 cos theta plus I into root 2 sin theta. Now comparing the both real and imaginary parts. So what you get? -1 is equals to root 2 cos theta. So cos theta value is -1 by root 2. And -1 is equals to root 2 sin theta. Sin theta value is -1 by root 2. So see here, both x and y are negative. X is less than 0, y is less than 0. So therefore theta belongs to third quadrant. So in that case the argument of z is minus pi plus theta. But what is theta value? It is pi by 4. So argument of z is minus pi plus pi by 4. That is minus 3 pi by 4. So therefore the polar form is minus 1 minus I is equals to root 2 into cos minus 3 pi by 4 plus I sin minus 3 pi by 4. So this is the polar form of a given complex number. So see the next one. So given z1 is equals to minus 1, z2 is equals to minus. So then find argument of z1, z2. So see here, this z1 can be written as minus 1 plus I into 0. And z2 write as 0 minus I into 1. So clearly z1 write as cos pi plus I sin pi. And z2 write as cos of minus pi by 2 plus I sin of minus pi by 2. So clearly argument of z1 is what? Pi. And here argument of z2 is what? Minus pi by 2. So therefore argument of z1 z2 is right as argument of z1 plus argument of z2. So what is argument of z1? That is pi. So pi minus argument of z2 is pi by 2. So therefore argument of z1 z2 value is pi by 2. So see the next one. Given z1 is equals to minus 1 and z2 is equals to I, then find argument of z1 by z2. So here z1 is equals to minus 1 plus I into 0. So z1 can be written as cos pi plus I sin pi. So therefore the argument of z1 is what? I. Next z2 is what? That is I. So z2 is equals to I. So z2 can be written as 0 plus I into 1. And z2 is what? Cos pi by 2 plus I sin pi by 2. So therefore argument of z2 is what? Pi by 2. Now find argument of z1 by z2. So argument of z1 by z2 is what? Argument of z1 minus argument of z2. So that is pi minus pi by 2. You will get pi by 2. So therefore argument of z1 by z2 value is pi by 2. So see the next one. Here 1 minus I into 2 minus I into and so on. 1 minus ni is x minus iy. Then prove that this one. So here given 1 minus I, 2 minus I, 3 minus I and so on 1 minus ni is equals to x minus I. And take modulus on both sides. So that is modulus of 1 minus I, 2 minus I, 3 minus I and so on 1 minus ni modulus is equals to modulus of x minus I. And this also written as modulus of 1 minus I, modulus of 2 minus I, modulus of 3 minus I and so on modulus of 1 minus ni is equals to modulus of x minus I. So clearly this is equals to square root of 1 plus 1, square root of 4 plus 1, square root of 9 plus 1 and so on square root of 1 plus n square is equal to square root of x square plus y square. So and squaring on both sides. So what you get? 2 into 5 into 10 and so on. 1 plus n square is equals to what? X square plus y square. So this is the required answer. So see the next one. If the real part of z plus 1 by z plus I is 1, then find the locus of z. So see here, let z is equal to x plus iy. Given z plus 1 by z plus I. So what is z? X plus iy plus 1 divided by x plus iy plus I. Now this is x plus 1 plus iy divided by x plus I times of y plus 1. So now multiply and divide x minus I times of y plus 1. So now this is x into x plus 1, that is x square plus x. So next plus iy into minus I into y plus 1, that is plus y square plus y. So plus I times of xy minus x plus 1 into y plus 1. So divide by x square plus y plus 1 whole square. So here real part of z plus 1 by z plus I is 1. So given real part of z plus 1 by z plus I is 1. But what is the real part here? So that is x square plus y square plus x plus y divided by x square plus y square plus 1 plus 2y is equals to 1. Now this is x square plus y square plus x plus y is equals to x square plus y square plus 1 plus 2y. So x square y square get cancelled. Now this is x minus y minus 1 is equals to 0. So this is the required locus of z. And clearly required locus represents a straight line. So see the sixth one. If the amplitude of z minus 1 is pi by 2, then find locus of z. So amplitude means argument, that means theta. So see here, let z is equal to x plus iy. So consider z minus 1, that is x plus iy minus 1. This is what? X minus 1 plus I into y. So given amplitude of z minus 1 is pi by 2. So that is tan inverse y by x is equals to pi by 2. So but here tan inverse, what is y by x? Y value is y only and x value is x minus 1 is pi by 2. So therefore clearly x minus 1 is equals to 0. This is the required locus of z and it represents a line which is parallel to y-axis. So see the next one. If the argument of z1 bar and argument of z2 are given, that are pi by 5 and pi by 3, then find argument of z1 plus argument of z2. So here given argument of z1 bar is pi by 5 and the argument of z2 is pi by 3. So you know that argument of z1 plus argument of z1 bar is 0. So that is the property of argument of z1. So see here, argument of z1 is what? Minus argument of z1 bar. So that is given pi by 5. So therefore, argument of z1 value is minus pi by 5. So now find argument of z1 plus argument of z2. So what is that? Argument of z1 is minus pi by 5 and argument of z2, that is what? Pi by 3. So this is minus 3 pi plus 5 pi by 15. So you will get 2 pi by 15. So this is the argument of z1 plus argument of z2. So see the next one. So express the 1 minus I in modulus amplitude form. So see here, let z is equals to 1 minus I. So clearly x is equals to 1, y is equals to minus 1. So therefore r is equal to square root of x square plus y square. That is root 2. So you know that z is equals to r times of cos theta plus I sin theta. But what is z here? 1 minus I is equals to root 2 into cos theta plus I sin theta. So this is equation 1. So now comparing the both real and imaginary parts. So that is 1 is equals to root 2 cos theta minus 1 is equals to root 2 sin theta. So see here, cos theta is equals to 1 by root 2 and sin theta is equals to minus 1 by root 2. So here x is greater than 0, y is less than 0. So then clearly this complex number lies in fourth quadrant. So that is theta belongs to fourth quadrant. So then argument of z is what? Minus theta. So clearly a theta is pi by 4. Therefore argument of z is minus pi by 4. So therefore the modulus amplitude form is 1 minus I is equals to root 2 into cos of minus theta plus I sin of minus theta. So that is root 2 into cos of minus pi by 4 plus I sin of minus pi by 4. So this is the modulus amplitude of given complex number. So see the ninth one. Show that the complex number z satisfying the z square plus z bar square equals to 2 is hyperbola. So let z is equal to x plus iy. Then what is z bar? That is the conjugate of this complex number. So clearly z bar is x minus iy. So given z square plus z bar square is equals to 2. So what is z value? X plus iy whole square plus z bar square, that is x minus iy whole square is equals to 2. So this is x square minus y square plus 2ixy, and here x square minus y square minus 2ixy is equals to 2. So here both terms should be get cancelled. Now we will get 2 times of x square minus y square is equals to 2. So 2 get cancelled. X square minus y square is equals to 1. So clearly the required locus is hyperbola. Okay. So for next session we will discuss new chapter